Hello everyone, welcome back to MGF1106. So last time we talked about geometry shape in two-dimensional space. So we talked about the feature of those geometric shape. We call the perimeter and area. Now we want to look at the geometry shape in three-dimensional space. And when a geometry shape in three-dimensional space, it has a feature we call the volume. Okay, so what is volume? So today in this video we will talk about volume of some geometric shape, and we will learn how to calculate the volume of those shape. Okay, so let's get started. So here volume. Okay, so what is volume? So volume is just is a feature of geometric shape, and the volume it measure is a measurement of the space. It's a measurement of space inside, okay, inside the shape, the geometry shape. Okay, so whatever the space, okay, is contained by the surface area outside, then we call the volume. And the unit for the volume is to be remember last time, because last time we do area. When we do area, it's a two-dimensional space, so the unit of area is meter square, right? But now we look at the volume. So volume is three-dimensional space, so the exponent is not the second exponent anymore, but it will be the third exponent, because there's three-dimensional space. Okay, and I will be talking about some formula to find the volume of a specific geometry shape. Okay, now let's start with the first formula. But we in this video, in this course, we don't have to derive, and we don't need to know the reason how to come up with those formula, how to derive the formula. We just use the formula to calculate and the volume, and to do practice only. Okay, so the first formula here, we want to find the volume of a square, of a cube. Okay, so you want to find volume of the cube. So the cube is just 6 square. Okay, it's just 6 square. So the cube look like this. 6 square face. Okay, together. So they look like that. Okay, so this is a cube. Okay, so all the surface over here is square. Okay, all of them is square. And over here, of course, we know the side of one of the square here, and we call the S. So if we know the measure of one side of the square, then we can find the volume easily. So the volume of the cube here will be V equal to S raised to the third power. Okay, just so you raise the side raised to the third power, then we have a volume of the cube. Okay, so that's the cube, and the second one is the sphere. Okay, so second one is sphere. Okay, sphere. Okay, so sphere is like a sphere is a ball. Okay, have the shape of a ball. So the sphere look like this, huh? Okay, it's a ball. Okay, show the ball. Okay, like that. Okay, and the ball here have the radius. Okay, and we can find the volume, which is the space contained inside the sphere right here. We can find the volume by using the formula here, V equal to 4/3 pi r squared. Now, what if I want to find the surface area of the sphere? The surface area of the sphere is not the volume, it's like the area. So we also have the formula to find the area of the surface of the sphere is 4 pi r squared. Okay. So in this section, we just focus on this one only. Okay. So that is for the sphere. Now the next one is the prism. Okay, so the prism, there's so many different type of the prism, depends on the base. So the base of the prism, um, it could be with the square, or it could be any polygon, as long as we know the surface area of that. So let's say that the prism I have over here, the base is the base over here is a square. Okay, okay. So let's say the base of the prism here. Let's say the base is the square. Okay, okay. So we have the prism look like that. So it look like you have a square, and you elongate, you stretch the square, spatially along the vertically, spatially and vertically up. So you will have something like that. Okay, okay, okay. So you have something like that. Okay, all right. There you go. So this is the square. So the base over here. So you have the top base and the bottom base over here. The top and the bottom right here is the square, and the all for surrounding surface over here is the rectangle. Rectangle, and we can find the volume of this one by multiply the area of the base, or and you multiply by the area of the base, and you multiply by the height. Okay, okay, which is give you the volume of this prism. However, there's so many different type of prism, depends on the shape of the top and the bottom base right here. Let's say, what if the bottom base over here, the top is they all rectangle, then you apply the same formula. Okay, then you apply the same formula. It could be like this. So what if you have the bottom is a rectangle, and you stretch the rectangle. Okay, okay, you stretch the rectangle here. Okay, and okay, let's stretch them. You can have something like that. Okay, okay, and you have something like this. So you see that they all are six faces here, they all rectangle. This is also prism. Okay, this is also prism, and we can apply this formula also. So in this case, the prism here, the base and top and the bottom here, the base over here, the rectangle. So the area will be the area of a rectangle. Over here, for this one, the area will be the area of the square. But the prism, it could the base could be a pentagon, or it could be any polygon. But you're gonna do you use the same formula. Okay, so let's say what if the base is a hexagon. Okay, so the hexagon look like that, right? So everybody know what hexagon. Okay, look at that, and we go ahead and stretch the hexagon. So you see that you stretch them. Okay, okay. Then you're gonna end up with something kind of something like this, right? I'm sorry, I cannot draw perfectly here, but I try to. So we're gonna have so something like that. Okay, okay, okay. All right. There you go. See that? There you go. So you see, for this prism, you have to find the area of the base over here. The area of the base over here could be, you have to find the area of the polygon over here. In this case, we hexagon. So in order to find the volume of this prism, it will be harder, right? Because you need to find the area of the hexagon over here. It takes a lot of time over here. Maybe you don't have the specific formula to find the area of the hexagon. You have to split them into the triangle and find the area. So this one over here will be tough. Okay, but for this prism and this prism, very easy. Sometimes the base will be a triangle also, if you want to. So then it becomes something like this. Okay, let's say you have the base. The base is a triangle. Then over here, Okay, you have something like that. Okay. Okay, so you have here. Okay. So this one. Okay, so the prism over here, the base is the area of the triangle. So we here the area of the triangle, we know the area of triangle 1/2 base times height. So as long as you know the height and you know the area of the triangle, you can find the volume of this prism easily. Okay. Okay. Now the third three-dimensional geometry shape I want to talk about is the cone. Okay, so you know what cone look like. Okay, I just want to make sure because sometimes I forgot the formula too, but I expect you guys to memorize it. Just sometimes you forgot, but doesn't mean that you should not memorize it. Okay, I believe is the formula of the cone. The formula of the cone volume here should be V. So the cone, first of all, the cone look like this. So you have the base is a square, it's a circle, and you have something like that, right? It look like an ice cream cone, right? And we have the height of the cone right here is h. So they have the radius over here. Okay, so here we can find the volume easily. So the volume is 1/3 pi r square h. So pi r square is actually the area, right? This would be the area of this circle. Okay, area of the circle. 1/3 pi r square h. All right. In order to find the area, surface area of the cone could be tough. Okay. I just provide you the formula. But again, we don't need to focus too much on that. So the surface area of the cone will be 2 pi r h plus 2 pi r square. Okay, which is this surface around and the surface of the circle right here. Okay, then the next one is the cylinder. Okay, so the volume of the cylinder. So the volume of the cylinder. So first of all, what's cylinder? Cylinder, we have the bottom face. The surface is the circle. Okay, and you have something like that. So it look like a prism, but the bottom surface is just a circle, and the top is a circle. So for this one, the volume will be a pi r square h. Okay, pi r square h. Oh, I think I put the wrong one right here. So I think this is the area of the cylinder, and the area of the cone over here. So will be cone will be a pi r square. This formula is crazy right here. I believe it takes a lot of time to memorize this one. So r square plus h square. Okay. All right, we're gonna do example, and we'll see if we can use a formula here to calculate the volume of the of some geometry shape. Number 6. So we have cylinder already. How about a pyramid? Okay, so pyramid. Okay, so in order to find the area, the volume of the pyramid. So the pyramid, so we know the pyramid, the Egyptian pyramid, right? The bottom is the square, right? So the typical example of pyramid would be something like this. So you have a square. Okay, this is square, and you have the pyramid going right at the center. So you have something like that. All right, that's a pyramid, right? There you go. So in order to find the volume, okay. it's kind of hard to draw over here. Okay, so in order to find the volume here, you need to find the area of the base. So the volume here will be V equal to 1/3 base times height, area of the base. Okay, you must find the area of the base. So I'm gonna go ahead and change a little bit here. So over here is area of the base times height. So height is from the top right here, okay, down to the bottom surface. So this is the height. Okay. Okay. And you see so many different type of pyramids. So you see the base in this pyramid is the square, but it could be a rectangle if you want to. So let's say the pyramid look like that. It could be, okay. So you can have something like this, and you have something like that. Okay, this is also a pyramid, but the formula will be the same. Or sometimes the base is a pentagon. Okay, let's say the base is pentagon, right, like that. Okay, so you have the center over here. So you have the pyramid look like that. So you see in this case, in order to find the volume of this pyramid over here, you see that you have to find the area of the pentagon, right? But this pentagon over here is kind of tough to find the area. So, but the formula is still the same. Okay, okay. The base can also be a triangle if you want to. Let's say whatever the base over here is a triangle, look like that. Okay, and we had a pyramid look like this. Okay, but the formula will be the same. Okay, and this is also a pyramid. Okay, it just you find the area up here, and you want to find a height, and of course, then you can find a volume, whatever the space inside this pyramid. Okay, so that's all the formula you need to use when you do example or you do problem. Now let me jump into the first example right away right here. Okay, so I have an example like this. Alright, so in this example, we want to find the volume of the shaded region. So think about it, you have a cone right here, a cone, okay, and inside the cone we have kind of what you recognize, the cylinder, right? And think about it, you want to find the purple space only, okay? So in order to find the purple space only, you need to find a volume of the cylinder of the cone, and you subtract by the volume of the cylinder, then you have whatever the volume of the purple space inside this cone. Okay, so that is the strategy. So you see the volume here, the volume of the purple will be the volume of the cone minus the volume of the cylinder. All right, so find the volume of the cone. So let's find the volume of the cone. So volume of the cone is 1/3 pi r square h. So let's see, we can find the radius over here. So we can have the radius of the cone over here, it will be 5, so it's will be 1/3 pi. So the radius will be 5/2 square, right? And the height is 11. So over here you can have 1/3 pi 25/4 times 11, which is give you, oh, it's a pretty big number. And it's not a nice number at all. So we have 25 times 11, then you divide by 12. So you have the 275 pi divided by 12. Okay. So the answer, you can go ahead and convert to decimal numbers. So I'm going to just go ahead and leave it like this. Okay, unless you might MATLAB want to convert to decimal number. Other than that, this is beautiful answer. So the volume here will be inch cube, okay, because it's three-dimensional space. The exponent over here will be third exponent of second one. Now I want to find the volume of the cylinder. Cylinder is pi r square h. So right here, the radius of the cylinder over here is the radius. This is the diameter, so the radius will be 2. So we have pi 2 square, and the height of this cylinder is only 4. So you have 16 pi. Alright, now you can find the volume of the purple area will be 275 pi over 12 minus 16 pi. Alright, I'm gonna go ahead and find LCD over here. So I multiply the top and the bottom over here by 12 to find LCD. So I have 16 times 12, which is 192. So you have 275 pi minus 192 pi over 12. Alright, 275. So you subtract and give you 83 pi over 12. Okay. Unit inch cube. Inch cube. Alright. See? It's not that hard, right? As long as you recognize you recognize the shape, then you know what formula you use. Alright. Now let's see if we can do another one. Alright, so look like we have the shape right here. Again, we want to find the area of the purple one, the brown space, the volume, not the area, the space, the volume of the purple section. So you see that you have a prism right here, but the prism over here, the base is the triangle. So in order to find the volume of the brown the brown part, you find the volume of the prism, then you subtract the volume of this rectangular prism. Okay, so this is triangular prism, and this is rectangular prism inside. So I'm gonna just change a little bit. So this they all prism, but this one is triangular triangle prism, and this is a rectangle prism. Okay. All right, now let's try to find a triangle prism first. So triangle prism, you need to find it. You have 1/3. The prism is a base time height, just no 1/3. Sorry, 1/3 is a pyramid, so just base time height. So the base over here is the area of the base time height. So area of the base over here is the triangle, so it will be 1/2. 1/2 base time height for area of the triangle will be 6 times 8. 6 times 8. Time height of this prism is 11. Okay, so you have 24 times 11, 264. Okay, inch cube. Okay, and now you want to find the volume of the rectangular prism over here. So you have the base times height. So but the base over here is a rectangle, so it will be length times width. So it will be length times width. The area is length times width. So 3 times 4 times 11. So this will be 12 times 11. So it will be 132 inch cube. Now then you see you can find the volume. It will be 264 minus 132, which is give you 132 inch cube. Here you go. See, very easy. All right, let's do another one. Last one, huh? See, it's not really that bad. For this one. Okay, this is look more complicated, but it's not really that bad. You see that you have a cylinder over here. You want to find the space, the brown space over here. You just find the cylinder. There's a volume of the cylinder. Then you subtract the volume of the 3 sphere over here. Okay. Okay. Well, you look at the picture, you see that the sphere over here, it touched the bottom surface of the cylinder. Okay. So right at the center of this. Right over here. Okay, so So the volume should be volume of the cylinder minus minus 3 volume of sphere. Okay, because I multiply by 3 because the 3 of them, they're all the same. So the volume of the cylinder is very easy. The pi r square h will be pi radius is 7/2 because this diameter you divide by 2 your radius, you square it and you multiply by 20.8. Okay. I hit decimal over here. So you mean what we end up with decimal. So we have 7 divided by 2. Then you square it. And then you multiply by 20 times 8. So the answer is 254.8 pi inch cube. Oh, centimeter cube. Okay. Leave the pi, okay? Leave the pi. Don't convert it because you convert it. This is kind of messy. Then you find the volume of the sphere is 4/3 pi r cube. So you have a 4/3 pi. Radius is alright. So the radius over here. So they give you this diameter. So the radius will be 6.9. 6.9 over 2 raised to the third power. Okay, 6.9 divided by 2, you raise to the third power. Then you multiply by 4, you divide by 3. Pretty messy number. So give you 54.7515. Please go ahead and check again for me. If you have a calculator over here, go ahead and check it again because I don't think I put it wrong, but go ahead and check all the math again. Okay, the logic is good, but sometimes I have careless mistake too. Alright, so now I can find the volume of the proud space over here. That would be 254.8 pi minus 54.7515 pi centimeter cube. So over here, so you take this minus, okay, 254.8 minus that. So you have 200.0485 pi centimeter cube. Then the answer kind of messy. It's not clean answer, but it's just because the height over here is 20.8. I don't know why they don't just change it. Why don't they just put the height is 20 and the radius diameter is 6? Then everything will be easy. They try to do this on purpose so that the final answer is kind of it's messy, but that's okay. But still the correct answer. Okay. All right. So on the test, I'm gonna just give you something like this. Maybe to some of you, memorize own formula here kind of tough, but it takes time. Okay, you have to do a lot of practice, and you're gonna memorize it. Okay. All right. Go ahead, watch this video carefully. If you have any question, please let me know. Please point out if I have any careless mistake. Okay, then I'll be seeing you next time.